Today, we're taking a seriously mind-bending journey into the hidden structures that literally govern our universe. We are going to explore these massive, invisible forces, some that are violently dragging our galaxy through space, and others that are actually pushing the very fabric of the cosmos apart. So grab your mental spacesuits because we are heading straight into the dark.
Right off the bat, I want you to think about something for a second. What if the absolutely most important parts of the universe are the ones we can't even see? We're so used to looking at bright stars and glittering galaxies, but recent scientific breakthroughs are showing us that the true drivers of cosmic evolution are actually hiding in the shadows. Here's our roadmap for today's explainer. We'll start with the incomplete cosmic map, move into the zone of avoidance, and unveil the Vela supercluster. After that, we'll dive into the mystery of dark energy, and finally, cosmic voids and surface tension. Section 1. The incomplete cosmic map, the missing pieces of our universe. Okay, before we can even begin to understand where the universe is going, we kind of have to admit that our current maps of the cosmos have a massive, glaring blind spot. Think of our view of the universe like a pie, but a whole 20% slice is just missing. Roughly a quarter of the local extragalactic sky is completely blocked from our view. Why? Well, simply because we live inside the Milky Way galaxy. When we try to look out into the broader universe along the plane of our own galaxy, all the dust, gas, and stellar crowding acts like a giant brick wall, and this completely skews our understanding of cosmic flows. Section 2. The zone of avoidance, the wall of dust and stars. Astronomers have a rather intimidating name for this blind spot, and while it sounds like a VIP area at a really terrible nightclub, it's actually been incredibly frustrating for scientists. The zone of avoidance is exactly that. The roughly 20 to 25% of the sky hidden right behind our galactic plane. Think of it like a locked, heavy door. Standard optical telescopes just literally cannot pierce through this wall of dust and stars. For decades, this has prevented us from having a full 360-degree picture of how and why our local cosmos is moving. But scientists have finally found a key to that locked door.
So how do you map what you can't see? Astronomers use this brilliant hybrid method. Step 1 involves grabbing over 65,000 galaxy distances from a massive catalog called CF4++. Step 2, and this was the real game changer, was using the Meerkat radio telescope. Unlike optical light, radio waves cut right through all that galactic dust, allowing scientists to detect the radial emissions of hidden neutral hydrogen gas. Step 3 brought all of this data together to map the hidden mass in a region we have never been able to clearly see before. Section 3. Unveiling Vela supercluster, a monster in the dark. And let me tell you, what they found hiding right behind the Milky Way's dust was absolutely staggering. To really grasp how massive this discovery is, let's look at the numbers. You and I, we live in the Lania KS supercluster. It's our local cosmic neighborhood containing the Milky Way and about 100,000 other galaxies. But this newly mapped Vela supercluster, it is nearly twice as massive as our entire home supercluster. It rivals the famed Shapley concentration, meaning it totally dominates the mass budget and the gravitational influence of the entire southern sky. Just let that number sink in for a second. The researchers found the central regions hold a mass of up to 33.8 times 10 to the 16th solar masses. To put that into an everyday perspective, that is tens of millions of billions of suns, all packed into an incredibly dense double-core structure that extends far beyond the galactic plane. It is a genuine titan. And until very recently, we barely even knew it was there. Okay, so why does this actually matter to us? Well, for a long time, cosmologists were dealing with this weird problem called the bulk flow tension. Basically, our entire local universe is speeding in one direction at an insane 400 kilometers per second, basically pulling galaxies toward the dark. Standard models predicted it should only be moving at about 90 kilometers per second. So where was this mysterious, massive pull coming from? Now we know. The immense hidden gravity of the Veil of Supercluster is the main actor here. It literally solves the mystery of the pull. Section 4. The mystery of dark energy, from pull to push, because gravity is really only half the story. Now, we are pivoting from the tremendous pull of these hidden superclusters to the exact opposite phenomenon, the accelerating push of the universe. We essentially have two competing forces shaping everything around us. On one side, we have the pull, over dense regions like Vela using their massive gravity to pull matter together. But on the other side, we have the push.
And to understand this, we have to look completely away from the brightest, heaviest parts of the universe and instead focus on the absolute emptiest regions, the vast cosmic voids. Section 5. Cosmic voids and surface tension, the bubbles of space. This brings us to a really radical new hypothesis. What if empty space isn't just empty? What if these massive voids actually have physical properties that are driving the expansion of the universe? If we look at the architecture of our universe, the cosmic web, you can see these bright nodes. Those are the superclusters, like Vela and Laniakea, connected by glowing filaments. But notice the immense dark spaces in between them. Those are the cosmic voids. And here's the crazy part. As the universe evolves, these supervoids are absolutely dominating the cosmic volume. They make up a significantly larger fraction of the universe than the actual matter does. Now, I want you to think about this brilliantly simple analogy. We can actually view this whole void-dominated universe like a giant bubble bath, or bubbles in boiling milk. The voids act as expanding bubbles, and those massive superclusters form the boundaries between them. As these giant empty spaces expand and merge together, the galaxies are squeezed in between them, exactly like the liquid trapped between soap bubbles. To explain how this actually drives the universe apart, scientists use a concept called cosmological back reaction. Traditionally, cosmologists treated the universe as perfectly smooth, just to make the math a lot easier. But this concept argues that the universe's lumpiness, that extreme difference between super dense clusters and completely empty supervoids, actually really matters. This structural difference creates real physical effects on a global scale. Let's piece this whole shebang together. If voids act like bubbles, the dense superclusters enclosing them basically create a boundary. And just like in basic physics, these boundaries create surface tension. At the cosmic scale, the average effect of all this tension creates an effective negative pressure. When you actually run the math on this, it yields the cosmological constant that perfectly mimics the exact value of dark energy. The push expanding our universe might literally just be the surface tension of expanding empty space. How wild is that? As the researchers so elegantly put it, vast voids are not only a key element of the cosmic mass and volume distribution, but also one of the purest probes for global cosmic parameters. For centuries, we have been totally obsessed with the glowing dots in the sky, completely ignoring the massive spaces between them. But it turns out the absolute nothingness is actively shaping the ultimate fate of our universe. So, I want to leave you with one final provocative thought today. If empty space acts like expanding bubbles, pushing the universe apart, and a hidden wall of dust conceals supermassive structures pulling us at 400 kilometers per second, what else is hiding out there in the dark?